Today, in this video, we'll be talking about the features of our product. The steel we use in the mechanism and barrel of our product is extremely important to us. We especially want to highlight this point. For the barrel and mechanism in our product, we use 4340 tempered steel. This material isn't produced in Australia. It's a material that costs twice as much as 4140 steel. The reason we use this is something we've noticed in a lot of materials. Of course, this is also related to the heat treatments applied. When we see products that have cracked here or there, each in a different spot with 4340 steel, and we've decided on the processes we'll apply to it, that is, the final processes we'll use, or rather, we're machining 4340 tempered steel. We're machining this material from 10mm rods, not casting it. Cracks from casting also happen in cast parts. That doesn't work for us either. In other words, we don't want even a single one of our products coming back to us with issues. After machining the material from the 10mm rod, when machining the barrel and mechanism, heat is generated on the surface. Because of this heat, a difference arises between the core hardness and the surface hardness of the material. To even out this difference, that is, to match the core hardness with the surface hardness, we 0.25. In other words, we put the barrel and mechanism through a special process. That is, we subject them to heat treatment. But in this heat treatment, we apply it from the surface right down to the core to a depth of 0 to 25 microns, and it stays in the furnace for 24 hours. Each piece is hung up individually and placed into the furnace. The material, in other words, we don't stack 30, 40, 50 or 100 pieces on top of each other and heat treat them all at once. Why is that? With this kind of heat treatment, the pieces on the outside end up harder, while the ones in the middle don't get as hard. So, for example, you might get 47 Rockwell here, 42 Rockwell over here, and let's say 35 Rockwell somewhere else. These sorts of problems crop up. That's why we hang them up one by one. Like I mentioned, it stays in the furnace for 24 hours. After 24 hours, we take the piece out of the furnace. We dip it in oil, wait for 10 to 15 seconds, then pull it out. As a result of this process, our material, which comes out of the furnace with a mottled colour, turns completely black. So there's no paint on the barrel or the mechanism. There's no coating either. And there's no Cerakote either. I'm scratching it with my fingernail, lovies. It's actually filing down my nail. I'm giving it a white. There's nothing at all. Why is that? After machining the material with a tool, the surface had softened. But with heat treatment, we restore the surface hardness and get that tough surface back again. Now, have a look at how this mechanism works. For instance, let me give you an example. Take a look over here. There's barely any friction involved. In a lot of products, it starts from here or from over there. There are options like that. All of S, design, drawing, we produce these straight from the CNC in this condition. On any part of our material, whether it's the mechanism, the barrel, or anywhere else after processing, right up until assembly, there's absolutely no filing or sanding done. In other words, nowhere in our finishing factory or outside of it are these products put through those sorts of processes. Let me put it this way. Normally, a part comes out of the CNC in half an hour, but after it's out, that half-hour part definitely needs to be filed or sanded outside. Foiling and sanding have to be done, but for our parts, they come out of the CNC in about 40 to 45 minutes, and we don't leave any chips or burrs anywhere on them. If you have a look inside, it's absolutely spotless. You can't even see any tool marks on the parts. No finishing process is done on the barrel, the mechanism, or any part of the gun. You can also have a look at the barrel like this. The barrel is also made in-house at our factory. Not sure if I'm able to show it clearly. The cartridge chamber fits in like this as well. A double coil spring is used. This part here is stale. First, you need to take this off to remove the firing pin. Second, you need to remove our latch here. Can you see it like this? I reckon you can see it. Third, you need to take out the pin here so you can remove the firing pin. This is a model that can have a red dot sight attached. Besides that, we've got a visual pattern for the cooler and suppressor. When I cock it like this with the firing pin installed, there's a firing pin indicator here. So our firing pin's cocked. That means there's a round in the chamber. Again, when there's a round here, it pops out as you'd expect. The extractor puts pressurized. The top part of the extractor is painted red. This also shows us there's a round in the chamber, or rather it indicates it to us. When it comes to the frame, it actually took us 3 years to develop this polymer frame. This material is almost 6 times more expensive than what most standard companies use. And it took us 3 years to source this material. What do we want? What properties did we want this material to have? Or rather, we had certain criteria. Our first criterion was that it shouldn't absorb moisture. Second, it shouldn't release moisture. Third, it should be impact resistant. Fourth, it should be heat resistant. We managed to find all 4 of these properties in this material. In other words, these 4 features are present in this raw material. Again, we can't get 4340 steel in Turkey. It also has to be imported. Like I mentioned earlier, this material isn't readily available in Turkey either. It's not something you can just pick up from the shop down the road. This is also a special material. Again, we have to bring it in from overseas. With this one as well, the point I made about not absorbing or releasing moisture is important because, as you know, even steel and other materials expand in the heat and contract in the cold. So they expand and shrink. You know how power lines sag in summer and tighten up in winter? Most raw materials, including steel, I'll say it again, can absorb and release moisture. We said it shouldn't take in or let out moisture. Why is that? If we send it somewhere with a mild or hot climate, our material will expand. When we send it to a cold climate, our material will contract, and because the working clearances and tolerances here are really tight, no matter what weapon it is, it'll end up jamming or getting stuck. When you work the mechanism, it hits the plastic frame, or in a lot of weapons, you'll notice this part, this section, sagging downwards. Basically, we definitely don't want anything like that in our weapon. I'm not sure what special feature this material is supposed to have, but as far as durability goes, if a material bends like that, to me, it means it's not the right material for the job. The moulding conditions for standard materials are between 180 and 220 degrees, but for this material, the moulding temperature is between 280 and 320 degrees. What does that mean? It means it's a material that can handle high temperatures. So at high temperatures, what do I want something that can withstand high temperatures, or what do we want that? No matter how much the weapon heats up during rapid fire, the upper part is made from plastic and it shouldn't melt, and the material shouldn't go soft because, as you know, with every shot, the mechanism strikes this part. What's going to happen when it gets hit? At high temperatures, the pins will heat up as well. When it gets hot, this area will start to loosen, click, click, click. In other words, this hole will start to get bigger. If it heats up during its forward and backward movement, you won't see any of these problems in this frame. So it's a tough and genuinely high quality material. Plus, when I talk about impact resistance, I try to bend it like this. I can't bend it at all. We've got one more video. It's a material we call crack crack. You know, the kind that gets pressed and hit, or rather it's a crack crack machine. With that, without this inner frame, even at its most sensitive point, none of these issues are present. We hit it here, trying to break it. We can't break it. In other words, we get worn out, but the material doesn't. That's why this material is absolutely essential for us. Again, we do the injection moulding of this material ourselves, right here in our factory. And after the material's moulded, it's not attached to any apparatus or shaping device at all. I mean, with a lot of materials, it's like this. They're held in place after moulding. A clamp is attached here, so this part doesn't drop down. This bit is fixed in a vise like this, so it doesn't move around. An apparatus is attached to the magazine slot so this part doesn't get narrower or deformed. In other words, so it doesn't end up a different shape. But this material comes straight out of our injection molding machine. It's a part we send directly to assembly afterwards. It's not attached to any shaping apparatus at all. The rear pad can be swapped out. We've got 3 pads, small, medium and large. You can adjust it to suit your hand. The magazine couch can be switched to either side. You can take it off from this side and fit it to the other side as well. It's got an option and feature so our left-handed mates can use it too. The magazine we use in the firearm is the C75B. In other words, it's a magazine that suits the C75B firearm, and it's made by Mecca, an Italian manufacturer. There's also a company called ACT, which is another Italian company. So, depending on what's available to order, their production status or delivery times, sometimes we get magazines from ACT, sometimes from Mecca, these 2 Italian companies, and include them with our product. You might be wondering, why Italian? From our perspective, it's all about the magazine. If there's a firearm, there's a magazine. If there's no magazine, there's no firearm. In other words, the better the magazine, the more it enhances the quality of your firearm. How should I put it? So we've made the firearm top-notch, but if our magazine isn't up to scratch, if it's not the quality we want or the right dimensions or whatever it might be, its shape, its form, its ability to hold or feed rounds, if those things aren't right, then our firearm just won't work. Since we don't want anything like that happening, what do? If we're using 4340 steel in the mechanism and barrel, we also make sure to use the best material in the polymer as well. So this time we're also making sure to use the best possible magazine. Overall, this is our safety model, our safety feature. We've got a trigger safety. If we press here, the trigger will release, but if we press from the side like this, it won't. Our trigger won't release. This trigger safety is designed for when you're trying to quickly draw the gun from your waist. It's a trigger safety designed to stop accidental discharge, so we don't end up shooting ourselves or having the trigger go off when we don't want it to. If I'm going to fire, I'll come to exactly this position. When I press the trigger, as soon as I press it, the trigger will release. Other than that, if I press from the side or pull it quickly, it won't release. Another thing we pay attention to, or want you to keep an eye on, is that even when I completely let go of the slide in this motion, it should still be able to lock in this position. I'm doing it this way because you're watching closely. Can you see any scratches or friction marks there? There aren't any. Then, for example, we've got a slight bit of thickness here on the barrel. The reason we've put this here is for shooting, so you can group the 3 points much better and into a smaller area. For target shooting, you can attach a red dot. You can also attach a laser. Reset distance. I've cocked it again. If you noticed, it's an ideal reset distance. It's not too long and it's not too short either, because if it's too short, it's actually pretty dangerous. Let's just say it's as it should be, or rather, it's spot on. If you ever come across our gun anywhere, this is something you can't really put into words. You've got to feel it for yourself. After you take up the slack on the trigger, just touch the trigger really gently. You can only feel the sensitivity of the surface between the trigger and the firing pin. It never drops with a click, click, click sound. It's a perfectly smooth surface. You can tell exactly when the firing pin is going to release. Otherwise, you're left wondering, did it drop? Is it going to drop? How should I put it? Or something like that. In other words, you'll feel this on the trigger. When you come across our firearm, we'll ask you to give this a try. Apart from this, we've got 3 types of frames. Or rather, we've got 4 colours, black, earth, grey and green. None of these here are Cerakote coated or painted. If you have a closer look at it from this angle, when you cut through the raw material, you'll see the exact same vibrant colour all the way through. So I've scraped the edge of this grey bit with a knife like this. Grey still comes out from under, mate. This means we use the raw material directly. In other words, we've got paint mixtures. We mix them so the material comes out coloured. We don't put any sort of coating on. Thanks for listening to me. Hope to see you again. Have a good day at work.